In this video, I'm intending to talk to you about the magnitude of a vector and then something called a unit vector, so I'll get to that later. So I think I alluded in an earlier video, and if I didn't, then here it is now. In the simple sense, the magnitude of a vector is just the length of that vector. And there's a formula for this. I'm gonna tell it to you now. So suppose that you have a vector A, which is, like has an x component, a y component, and a z component. So if the vector A is x comma y comma z, or is the column vector x, y, z, then the magnitude of A, and we use it's the same notation as absolute value bars. Absolute value bars just mean magnitude. This is going to be the square root of the x component squared plus the y component squared plus the z component squared. If it was only two dimensions, in other words, if you didn't have the z here, that's fine. You just wouldn't have the z squared here. Not a big deal. The magnitude of a vector is simply the sum of the components squared and then the square root of that. That's the magnitude of a vector. It's always positive. So I've got a quick example down below. Find the magnitude of the vector b, which is 3i minus j plus 5k. You should be able to do this one on your own. I suppose the one thing I would say is first of all, do we recognize what this is? Do we recognize that this is just a vector with components 3, negative 1, 5? Now that you have that, you should be able to easily come up with the magnitude of this vector. So according to our formula, the magnitude of vector b should be the square root of 3 squared, which is 9, plus 1 squared, which is 1, plus 5 squared, which is 25. This gets me the square root of 35. And so that is the magnitude of our vector. Really not a big deal. Very easy thing to compute. Here I have another example of a magnitude question. In this case, they'll tell you the magnitude. They'll tell you the magnitude of the vector 3 to r is the square root of 34. Find the value of the constant r. To be honest, I think you guys should be able to do this problem on your own. So pause the video, try it on your own, make sure you got it. So we know the magnitude of a vector, the square root of, the magnitude of b is supposed to be the square root of, the sum of the components squared. So in some sense, we know the magnitude of this vector is 3 squared plus 4 squared plus whatever r squared is. So now we have the square root of 34 is 9 plus 4 plus r squared. If we square both sides, we should be able to solve this. 34 is 13 plus r squared. That means r squared is 21. So r is plus or minus the square root of 21. Now, I mentioned earlier that the magnitude of this vector has to be positive, but that doesn't necessarily mean that the components are going to be positive. We could have positive square root of 21 or negative square root of 21 here. Either one of those would be acceptable. So the next segment of this lesson concerns something called a unit vector, and it's a really basic thing. A unit vector is just a vector that has a magnitude of 1. This may remind you of the unit circle. The unit circle is called the unit circle because it has a radius of 1 unit. A unit vector is just a vector that has a magnitude of 1. It's 1 unit long. Okay. And if you're given some vector, you can always find a unit vector that's in the same direction by taking your original vector and just multiplying it by the reciprocal of the original vector's magnitude. That sounds complicated. It's really not that big a deal. I've got an example here where I can show you that. So, to find a unit vector in the direction of this vector, the first thing we do is we find the magnitude. Right? So, pause the video for 15 seconds, find the magnitude of that vector. You should find that it's the square root of 1 plus 25 plus 4, which is the square root of 30. And so once you have that's the square root of 30, the idea is, and I want you guys to understand this vector is the square root of 30 units long. So if I wanted to sort of cut it down, I could take that vector and I could multiply it by 1 over the square root of 30. So then we could finish writing this answer by just distributing that in and ending up with negative 1 over root 30, 5 over root 30, and 2 over root 30. Okay. And this is a unit vector that is in the same direction as this vector. Now, I worry that example wasn't very clear. Like, I know you guys, we did it, we got the right answer, but I sort of want us to understand that a little bit better. So let me attempt that again. Suppose that you have some vector, like let's say the vector 4, 2, 4, right? My first question would be how long is this vector? Right, well, we can find that out. The magnitude of this vector is the square root of 16 plus 4 plus 16. This doesn't necessarily need to be in your notes, I just bear with me for a minute. So the magnitude of this thing would be the square root of 36, which is 6. So that means this unit is 6 units long. Like if I were to sort of draw this vector, the idea is the whole thing is 6 units long, right? How could I come up with a vector that is in the same direction but is only 1 unit long? The idea is if I took my original vector and like divided it by 6, in other words, multiplied it by 1/6, I'd end up with a vector that's 1 unit long, right? I'd end up with 4/6 and 2/6 and 4/6. This had ended up being 2/3, 1/3, and 2/3. Okay, and I hope that makes sense. The idea is you're just taking a vector that's a certain length long, and you're just scaling it down to that by dividing by whatever that magnitude is. Hopefully that makes sense. So the example we're about to consider is a slightly more difficult example. Part A should be really easy for everybody. Part B, I haven't shown you exactly how to do it, but it should be reasonable. And Part C, oops, I need to change the name of that. Part C is harder still, but still something that's attainable. So we're going to sort of walk through this now. I definitely feel like all of you should be able to do Part A on your own, so definitely pause the video and try that one out first before you watch me do it. So finding a unit vector should just mean that we find the magnitude of A and then divide by it. The magnitude of A is the square root of 1 plus 4 plus 4, which is 3. I'll save us some time. So that means the unit vector is 1/3 of -1 to -2. So I'm getting my answer to be -1/3, 2/3, -2/3. Now, if you wrote your answer in angle bracket form, that's fine. I've mentioned before I'm a fan of column vectors, so that's how I write my answer. Okay? So that's part A. Right? Part B. We now want to find a vector that's in the same direction, but has a magnitude of 18. So if you think you've got an idea here, maybe, think about your idea and see if you've got a thought there. If you don't, then the hint I would give is, we just found a vector that has a magnitude of 1. This vector is 1 unit long. If I want a vector that's 18 units long, it's almost like it would be 18 times bigger than this. ... So if I were to just multiply my unit vector by 18, I would take it from being a 1 unit long vector into being an 18 unit long vector. Right? So if I distribute that 18 in, I'll get -18/3, 36/3, and -36/3. And that simplifies down to just being -6, 12, -12. This thing is now a vector that has the same direction as both of these, but now has a magnitude of 18 because it's 18 times longer than the 1 unit long vector. And that really, in my opinion, is like the main use of unit vectors. If you want to find something that's 18 units away, chop it down to being 1 unit, and then multiply it back up to being 18 units long. So now we get to part C, and I like part C a lot, so make sure you've got your brain turned on for this. Hence, so again, it's a hence problem, which means, we're going to use what we just did. Hence, find a point that's exactly 18 units away from C in the direction of vector A. So what did we do? We took vector A, we cut it down to being a 1 unit vector, then we moved it back up to being 18 units, and now they want me to find a point that's 18 units away from C. So the idea in part C seems to be, if I just take point C and add this vector onto it, I'll get there. The issue is it's really not legal to add a point and a vector together, like completely different things. So it's like I have to find a way to take this point and represent it as a vector. If only I had a way to write a vector for the position of that point, like a position vector. Hey, wait a minute, we could write the position vector for OC, right? So if I just take OC plus this vector, right, and what was C? If we look back at the problem, C was the point 315, so that would be the vector 315. If I add that to my -6, 12, -12 vector, it will give me a vector that's pointing at what I want, -3, 13, -7. Now there's one catch. If you read the question, it says that it wants the point that is 18 units away from C. So it's sort of like we started with the point C, we changed it into a vector, we did a bunch of vector stuff, and our answer was a vector. Our final answer needs to be the point version of this vector, which is the point -3, 13, -7. Now, this example was a little bit more challenging, but it's the kind of thing you may be expected to do on the IB exam, so I just wanted you to have some exposure to it. I'll see you in the next video.